Okay. Hello everyone. Okay. Hope we are audible. Yeah. Okay. Hi everyone. Good day. I think good evening or good morning. Thanks all for joining this live streaming session today. Um, it's almost after a year. Actually, almost after 12 months, we are starting back this live streaming or live knowledge sharing session here again. And thanks for your interest and thanks for your questions and thanks for your support. Today we have an interesting topic. This is about Red Hat Enterprise Linux at the Edge, and we have a very special guest joining us today to explain us, okay, what is it and how useful it is, and what are the benefits of using this RHEL at the Edge. I'm not the guy, so Rahul will share with us the details, and I think we have a demo also. Yeah, not much formalities. If you have any questions, please ask in the chat anytime. Depends on time. We will be answering these during the session or after the session, or yeah, anytime. We will answer for sure. If it's not clear, of course, we will take it back and reply or post somewhere. Yeah, no other formalities. Thanks, Rahul, for joining this first of all and sharing with us. And yeah, please, stage is yours.
All right. Thank you, Gineesh. The pleasure should be mine. Thanks for inviting me into this session. All right. So, to get started, today we will talk about two things. The first one is MicroShift, and the second topic is RHEL for Edge. But primary focus will be on RHEL for Edge. There will be a demonstration as well, trying to understand how RHEL for Edge really works, and a little bit of explanation on MicroShift. MicroShift is not GA yet. We are going to release that as a technology preview in OpenShift 4.12, which is coming up in November 16th. So these are the two topics. Myself, Rahul Vijayan, I'm a go-to-market specialist in Red Hat. I closely work with Gineesh as well. And once again, thank you, Gineesh, for inviting me. So let's get started with the Red Hat's vision about Edge, or what are the different configurations we have at the Edge when it comes to solving the business challenges, especially focusing on Edge part of it. So first, let's go and talk about what's happening at the cloud or the data center side of things. So on the right bottom, you see a OpenShift configuration, which is, let's say, as a block diagram, cloud or data center. And that's a place where we normally position the full-fledged OpenShift, mainly used for application development, delivery, and things like that. And nowadays, we don't talk much about OpenShift. We talk about OpenShift Platform Plus, because that's a way we can address bigger challenges. Say, for example, OpenShift Platform Plus consists of 5 different products. OpenShift, then we have Advanced Cluster Management. That's a product which we use to manage multiple different clusters, compliance, and so on. Cluster security. How do we have standardized security across different clusters? That's we use ACS. Then we have QA for registry, and finally we have software defined storage, which is ODF. So everything comes together to provide a full-fledged solution, and that's how normally we go to market nowadays. OpenShift Platform Plus, and on top of that, developers use that platform to develop and deliver their software as fast as they can using automated solutions. So minimum footprint over there when it comes to cloud or data center is 5 different nodes. So 5 nodes, 3 4 control nodes, and 2 4 worker nodes. From there, when we move to the left, which is a decentralized data center, let's say it's a small data center in a town or something. Normally, you would have seen some of the shopping complexes in India or Indonesia or in other places have data centers in shopping complexes where they use the power and the cooling from the shopping complex itself. In such places where they have 2 or 3 racks, where they are space constrained, but at the same time they require high availability solutions as well. In such kind of scenarios, we have a 3 node configuration where the control node and the worker node are being co-located. Worker node is a place where you run your applications. Control node is a place where you control the whole cluster. So 3 node configuration where everything is being condensed, but at the same time I get high availability. When I move up, which is a remote worker nodes. The same concept, I have space constraints, but at the same time, I have robust connectivity to that place. That means I place a single node server as a worker node where my application runs, but it is being centrally managed somewhere far away. Only caveat for such kind of solutions is that you need a connectivity so that things continues to work. And finally, when you go one level up, you see single node servers where I the condition over here where I need to say that I don't have connectivity at all. So the connectivity is not so strong. I need an independent configuration where I put the control aspect as well as the worker node into one single server. Same concept. I have a lesser footprint, but at the same time I need some control over it. Has to be independently running. I cannot depend upon somebody who is remotely controlling because my bandwidth is not that great. So these are the OpenShift configuration. From here, we are getting to the edge devices. That's a place where we are talking about MicroShift and RHEL for edge. So which is at the very small, very small edge devices, which we call it as field deployable devices. Now, how does the configuration in the sense like how do the resources looks like CPU and RAM looks like on a data center or a cloud? When we have a full-fledged OpenShift configuration, the minimum we require is 6 cores and 24 GB. And when we go up, you can see MicroShift, which is at 2 core and 2 GB, which is the minimum configuration which we require, minimum resources required to run MicroShift. And as I mentioned, it's a technology preview, not being GA right now. So it will be released as a technology preview coming up in OpenShift 4.12. And then when we go one level up on Red Hat Enterprise Linux, 1 core and 2 GB. Have you ever thought about having Red Hat Enterprise Linux running as in 1 core kind of a device? So that's a kind of innovation we are bringing into the operating system world as well. So it can really run on a very small field deployable devices. So I'll stop here and I have to go back to the lab because there is a demonstration. I need to start the lab so that our lab is a little slow. So we let me start the lab and then it takes around 2 minutes. So by that time we'll come back to the presentation and we'll start. So we'll launch the lab. So this lab is all about showcasing Red Hat Enterprise Linux at the edge. How do we create an image? How do we deploy that image on an edge device? And then how do we update that edge device? When I say edge device, we are going to use virtual machine as an edge device because we don't have a edge device as such. So let's launch the lab. It takes around 2 minutes. So I'll go back to the presentation and we continue there for 2 minutes and then come back. All right. So normally when we talk about OpenShift or RHEL for Edge, or even when we talk about MicroShift, normally we get the question, how to select what are the different places where I can use. So OpenShift, we all know that. OpenShift is very clear. Whenever it's a high performance use case or when it's a full-fledged use case, OpenShift comes into picture. So that's on the right side. On the left side, we have RHEL for Edge and then MicroShift. So say for example, I have an application which is static. That means I deploy an application which can run for 1 or 2 years or 3 years. I don't have to touch it. Everything runs by itself. I don't have to even update it. And there is no new functionalities going into that application. In such kind of scenarios, that application can run as a container on Red Hat Enterprise Linux, or it can run as a package in the operating system itself. So basic idea is that the application is static, it's not changing. So in such cases, RHEL for Edge makes a perfect choice. In on the other side, when your application has to be continuously updated, new features has to be updated at the edge location, probably you require a full DevOps capability. In that case, Kubernetes makes sense, and that's a place where MicroShift comes into picture. So what exactly is a MicroShift? The base product is Red Hat Enterprise Linux. On top of that, when you deploy a minimum number of APIs from Kubernetes, it becomes MicroShift. So its a base is going to be the same for both the products. Now let's go back to the lab and see whether it is ready. If so, we'll get started with the lab. Okay, it's still taking time. 2 minutes not yet covered. So I'll explain what are the different things we'll go do in the lab. In the lab, we are going to create an operating system. Uh, we are going to download that operating system, deploy that operating system on a virtual machine, considering that as an edge device, and then later adding a package to it to say that we are updating that particular edge device. That's a whole set of labs we are going to do today. Okay, still slow. That's our labs is. So it's a live lab and it's a controlled environment. So I hope it's not going to fail on us because it's controlled and totally managed in the cloud. We're just running a lab remotely. And one more point over here is at lab.redhat.com. Anybody can access this. It's completely free for anybody to use it. You can give it to your customers, partners. You can use it yourself. No registration required. Everybody gets access to the lab, and you can run. It has around 13 to 15 scenarios, I believe, on Red Hat Enterprise Linux. So you can learn Microsoft SQL Server on Red Hat Enterprise Linux, Insights on Red Hat Enterprise Linux, performance tuning on Red Hat Enterprise Linux. So variety of scenarios available in the lab which you can use. Okay, the lab is ready to use. Let's start the lab. So, so in the lab, on the right side, to get oriented with the lab, on the right side, we have the instructions, the steps to do the lab. On the left side, this is a management virtual machine where we will perform some of the tasks to get this lab done. So as a first step, the lab asks us to go to hybrid console. So let me explain what hybrid console is. I'll click on that. So I log in as a lab user. So where do I log in? So I have my credentials here. Since I already logged in previously, it automatically log me in. This is the credentials I have used to log into the hybrid console. So let's talk about the hybrid console. So hybrid console is a user experience, customer experience kind of portal for us, where you can manage and operate all the different products, multiple different products from Red Hat, as OpenShift, Red Hat Enterprise Linux, Ansible, and application and data services. So today we will focus on Red Hat Enterprise Linux, where we will focus on edge management capabilities. So let's see what is the next section of the lab. So I click next. So the first step is create an operating system image for your edge device. So that's what the lab asks us to do. So let's get started on that step. On the right side, we see the steps. So we are going to create an image using a graphical user interface, which is completely running on cloud, where we are going to create a edge image based on Red Hat Enterprise Linux. For that, I will expand my screen, manage images. I create a new image. I name it as Monday. Today is Monday. I name it as Monday. I create an image based on Red Hat Enterprise Linux 9, and I'm creating an ISO installer. So let's go to the next step. So over here, we are going to provide the username and the SSH key of our management machine so that later we can log into the edge device to perform some of the activities. So let's go back to the lab and get the SSH key. So go to the lab manual. When I go down, okay, here is the SSH key of this management machine. So I copy that SSH key. I know the username RHEL. I come back and type in the username and paste the SSH key. And then I move forward. So I can add custom repositories, which I'm not doing in this lab. So I'll move forward. not adding any of the custom third-party repositories, say for example. And for fun, let's add one package. Let's say we want to add Vim. I search the package. Let's randomly add one package to it. So I'm trying to create a customized image. I'm trying to mock a creation of customized edge image. I move it over here and then click next. So over here, I'm named as Monday, version number 1, because it's the first version of that image which we are creating based on Red Hat Enterprise Linux 9. I have given the credentials of my management machine so that I can log in later. And then I click create image. So it starts to create a image named as Monday, version number 1, and it kickstarts the image build process. It takes some time to do this. By that time, let's look at the uh, lab steps. So we have done all these steps. We created that image, and the image is getting created. So we go to the next section of the lab. So next section of the lab tells us to download the operating system which we created just now using the hybrid console. Hybrid console is the one, this is the one which we used to create that particular image. Now we have to download that operating system image which we created. So let's start that lab. On to the right, we have the steps. So it says that copy the link and download that operating system image into this particular virtual machine. So let's do that. So over here, you can see that Monday, the image name, it's getting created and it takes around 30 minutes. Actually, the lab is slow. So what I have done is I have created few other images. Like yesterday, I created one Sunday, and Saturday images has been created because I created over the past few days. I have been experimenting on this lab. So let's use Sunday as an image where we can download that and start deploying the edge device. So I click on Sunday, the image which I created yesterday, click on actions, right click here, right click on that, copy the link, and then go back to the lab and then download on my virtual machine. So for that, I get to images folder. I use a script. A script is already being built in the lab itself, so you don't have to write that. It's already there. It has all the credentials to fetch the image from the hybrid console. So I copy paste the link and then click enter to download the image. So can you guess what would be the size of this RHEL image? Normally, RHEL image, if you were to download from our website, it's normally 8 GB, 9 GB, around 10 GB size. But what would be the size of a edge image which we are creating right now? It comes closer to almost 2 GB. That would be the size of that edge image. You can add as much as packages you would like to, depending upon what kind of application you are running. So over here, as an example, I only added one package, which is the Vim package. So in another few seconds, the image should be downloaded. So by the time, let's look at the next steps. So I went to that folder, I downloaded the image using the script. So the image is downloaded. The size is around 2 GB with the name uh, Sunday. Sunday is the image which we downloaded. So let's go to the next lab. So we downloaded the image onto my virtual machine. So now the lab asks us to install that image on an edge device. Over here, we don't have an edge device. Instead of that, we use a virtual machine as to show the demo. So let's start that. Okay, so in order to install the virtual machine, we will use the graphical user interface of this particular management machine. So you might have heard about the cockpit, which is the Red Hat Enterprise Linux graphical user interface. Yeah, looks like our graphical interface is safer to access. Let's proceed here and let's check the password to log in as well. So if I go down, I can see the username and password here, RHEL and Red Hat. And I log in. So this takes us to the cockpit, which is a graphical interface of my management virtual machine. So in order to run certain administrative commands, I have to turn on administrative access using the same password, which is Red Hat, authenticated. And then I can I can create a virtual machine from the graphical user interface. So you all know that Red Hat Enterprise Linux can act as a hypervisor as well, where you can run virtual machines. On the left, over here on the left, you can see different options. So if you are not so familiar with Linux, graphical user interface is rich now. You can use that to start working on some other things. The learning becomes much more easier if you are not so familiar with Linux operating systems. So virtual machines, we are going to deploy a virtual machine, create a virtual machine. So we already have the administrative access. I click on create VM. So I put Monday. Let's name it as Monday. Locally, we have downloaded it. The path is images. The image is Sunday. So the Red Hat Enterprise Linux 9 comes up and then we create the machine. So once it's there, we can click on the virtual machine and start the installation process. Okay, let's start the installation process. It takes around 2 to 3 minutes to install the virtual machine. By the time, let's go back to the presentation and continue with the presentation. Once it's done, we'll come back and continue with the lab. Okay, so we were talking about what are the different workloads or use cases where we use Red Hat Enterprise Linux versus Red Hat Enterprise Linux for Edge versus MicroShift. Okay, so in the lab, we are doing all these things which is mentioned in this slide. So we did a quick image generation from graphical user interface using the hybrid console. That's a place where we used to create that image. Then edge management, we can do edge management using hybrid console itself. We'll go through that in the coming up steps. Efficient over the air updates, this simply means that when you make changes to your operating system, say for example there is a security patch to be applied or there is a bug which I want to apply the patch for, I create a new version out of the same operating system image, apply the patches, and then click on update. It actually sends that just that change across a wire to the edge device. So it's very efficient in a limited bandwidth configuration. Now we have the ability to pass that change to the edge device, which makes it much more easier to send our patches and updates to the edge locations. So that's what efficient over the air updates. At the same time, when you did that change and when you were booting it up, if something happens in between, we have rollback options as well. So in our lab, we are not doing the rollback as such. I haven't tried as well, but that is one of the features which we require, because if something happens at the edge, we can't send somebody all the time to fix that booting problem. So we should be able to fix it remotely itself, and that's one of the capabilities which has been added to Red Hat Enterprise Linux. Before we get to MicroShift, let's complete the lab and come back. Let's check whether the installation has been done. Still coming up. Okay, let's connect and see whether the installation is completed. Okay, it's still going on. So let's talk about MicroShift and then come back. Okay, so what exactly is MicroShift? So till this point of time, we were talking about RHEL for Edge and how that is going on, and the demonstration is also based on RHEL for Edge. So MicroShift, on the left you see OpenShift, and on the right you see the MicroShift. So OpenShift is very, we all know about it. It's based on RHEL Core OS, so it's an immutable operating system. We can't make any changes to that operating system. It's based on a distributed architecture, as in when you want to grow, we can keep on adding nodes onto it and it will scale out. So it's a distributed architecture, it's a cluster architecture, very straightforward. And then we have operators sitting on top, which makes our life easier in terms of managing and operating your applications and workloads and databases and so on. And then on top of that we have Kubernetes APIs, which can be used to, let's say for example, you want to manage your multiple clusters. For that we use ACM, which you see on top, which is at bar, advanced cluster management. That's a tool which we use to manage OpenShift clusters. Not only manage workload placement or even compliance policies can be also be done from ACM. So that side is OpenShift, which is very performance oriented. We You can't make much of operating system customization because it's immutable and it's managed through ACM. On the right side, we see MicroShift, and as we discussed, the base product is RHEL for Edge. And on top of that, we deploy the minimum set of APIs or Kubernetes APIs, which makes it to MicroShift. And then we can manage it through ACM as well. That is because it is Kubernetes APIs. But here we have two things to be done from a management perspective, because we have two different things. The base is RHEL operating system, and then we have a Kubernetes layer as well. For the base operating system, we use Fleet Manager to manage and operate at scale. And that's exactly what we are doing in the lab. So we are using hybrid console as a way to manage and operate the RHEL for Edge fleet. And one more important thing is that these are all independent devices. MicroShift cannot be clustered today. So if you deploy MicroShift on a field device, it is an independent device. You cannot add one more and scale out. That feature is not available. Probably it's not required. Maybe in the future it's there. As of now, that use case is not being seen. Okay, let's go back to the lab and see whether the virtual machine is being deployed. Okay, it's being deployed. So let's go back to the lab and see what is the next step. So we have deployed the virtual machine. Okay, now it's a time to connect to that edge device. So we'll copy the command. It's very easy, lab. I don't have to type the commands. It's very easy. Just have to copy paste. Click on the button and it's already copied. Then I log into the edge device. We are already into the edge device, and after that we have to change it to root access, then change the name of the edge device so that it becomes meaningful. And then after that, this is a critical step. After that, we are connecting the edge device, RHC connect, using our credentials. We are connecting our edge device to the hybrid console. And this is the name of that edge device which we created after the host name change. So we are using a command to connect our edge device to the hybrid console so that later we can manage the edge device from the graphical user interface itself. And over here, we can see that it says that it's connecting to Red Hat Insights. So what exactly is Red Hat Insights? So Red Hat Insights is a tool which comes with Red Hat Enterprise Linux, which help you to identify all the different proactive issues or challenges. Proactively, it will identify all the different challenges across performance, reliability, secure vulnerabilities, CVEs. All those things can be proactively identified and it can fix it. So easy way to understand this is, if I were to ask you a question, could you tell me all the different issues which you did not know about in your environment, all the different challenges? So, how could somebody tell all the different challenges which you did not know about? And that's exactly what Red Hat Insights will do. Red Hat Insights proactively will tell you all the different challenges which you did not know about, and not only telling you that different challenges, but at the same time it will give you an answerable playbook to remediate it. So it can proactively tell you in a dashboard, these are different set of challenges you have in your environment, CVEs or performance issues. Let's say for example, I have two nicks, one of the nick card is down. Insights will tell you that, and insights will tell you that, and probably will give you a ansible playbook to fix that as well. If there is a CVE and which is a published CVE, we might give you an ansible playbook to fix that CVE as well. So insight is a insight is a tool which you don't have to buy it. It comes with Red Hat Enterprise Linux. And then we have to we are also going to register insights. When we register insights with this edge device, it starts collecting data, so that we can later know what are the different things we can with different issues we have with this particular edge device, and how can we fix that. So two commands which we ran in order to get insights up and running. So once that is being done, we will see that machine getting reflected in the hybrid console. So let's see if it's already there. So we go to the inventory, we go to the systems, already there. F991E. Let's go back to the lab and see whether it's the same thing. Yeah, F991E. So hybrid console gets reflected here. From here, I can manage all the edge devices. So these are some of the images which I created yesterday. That's why you see yesterday and day before. That's why you see a list of edge virtual machines over here, and I can manage it from here. So now let's see the next set of commands. What does the lab ask us to do? Okay, we can proceed to the next section. Okay, now it says that update the image on your edge devices. So until this point of time, we use the hybrid console to create an image. We downloaded that image onto our virtual machine, the management virtual machine, created an edge device, deployed that image onto the edge device. Now the lab is asking us to update that edge device. As an example, I deployed an edge device. 6 months later, I have a maybe a security issue. Security patch has been released. I have to update that. Let's use that as a scenario to think about this lab. So I have to update the edge device. In order to do that, so let's get to the image which is in hybrid console, and then update that image which with one more package. So go to manage images. So let's use Saturday, the image Saturday, because Monday is still building. The lab is really fast. So let's use Saturday as an image, which I created 2 days before to do this part of the lab. So I go to Saturday, the image which I created 2 days before, create a new version of that image. So I want to go back and show you one thing. The version is 1. So once I add that new package, the version becomes 2. So create a new version. No need to add a description. So I'm creating an ISO image. Actually, ISO image is not required because we are updating that particular image. So we don't have to download that. We are not adding custom repositories. Let's say, for example, we want to add SSH package. So earlier we added Vim. Now we are adding some random packages. Let's say OpenSSH. And next, it version becomes 2 based on Red Hat Enterprise Linux, and then we are updating that image. So it takes some time to update that image. Let's go to the systems and see how is it, not systems, sorry. Let's go to the images and see. So Saturday is getting updated as well. So what the lab says is that once the image is updated, I can go ahead and update my machine. So for that, I can show you how we can do that. So we go to inventory, I go to systems. I have done this for some other machines yesterday. So you can see that update is available. So for these edge machines, there is an update available because I made some changes to that underlying image. So I can click over here and I can click update. Once I click update, what happens at the back end is the update is being sent to that edge device. Then the system gets rebooted, and then system the new package is being updated. So I can do few things here. If I don't want to apply the patch right now and do a reboot, I can do it in a scheduled manner as well. Also at the same time, if the system cannot reboot because of certain reasons, I can roll back to version number 1 as well. And that I have not tried. I would like to try that one day to see how really that works as well. So these are some of the things which we have innovated into Red Hat Enterprise Linux, so that the edge management becomes really really easier. Okay, that was a whole thing about the lab, and I wanted to cover a few things about one more concept called Fido. We'll go there. So we have done the update device, and normally when we update, if you go to that virtual machine, we can see that it is getting updated. Since I have used an image which was 2 days before, I don't have that virtual machine live, so I'm not able to show that. But that's how you can see that your image is getting updated. All right, I go back to the presentation and want to share about one more concept, which is the Fido. Okay, so we talked about MicroShift, and we ended saying that MicroShift cannot be clustered; it has to be single devices for now. And one more concept, which is FIDO. So FIDO actually means that it's a fast identity online. So at a very very high level, a very high level, uh, how do we use to deploy edge devices? So when we think about really edge far edge devices, there are thousands of them. So which means that I take the device, I I myself will transport to an edge location, configure it, connect it, and then come back. Which means that I have some capability, I have some skill set. I need some skill set to configure it at the edge place, at the edge location, and then connect and come back. Doing it at 1,000 places, I have to go to 1,000 locations, or I have to send 1,000 people, which can be really costly. So how do we solve that problem? So when we thought about that problem, when we in the sense as an industry, when we thought about that problem, we came up with a solution that how about pre-packaging everything into the edge device and then send it. So everything is being configured, password, certificates, all the things are there, operating system image is there, application is there, everything is there. Somebody has to go there, connect, and power on. That is a good solution, but the problem is somebody can somebody can steal the passwords, somebody can hack into the device because they are physically carrying it. I can hack into the device and I can steal the passwords and certificates and so on. And that's a place where Fido comes into picture. So Fido actually helps in creating a secure channel. So before we get there, what happens is nowadays with the help of Fido, so we do bare minimum installation. So we create, let's say, bare minimum into the edge device, and then we ask the person to go to the edge, power on, and connect it. Then once the connection is done, it creates a secure channel between the edge device and the manufacturer, as an example, and it creates a secure channel, and then the manufacturer or the owner of the device can start configuring it remotely, and that solves the problem. And for that to be done, we use Fido. Fido is a way to create that secure channel to make sure that, say, for example, if the device is tampered and once you connect and powers it on, if it is tampered, probably the owner doesn't allow it to be configured because it is being tampered. So there is a kind of secure channel being created so that you can make sure that whatever configurations, passwords and certificates which you send is to the real device itself. So there are a lot many concepts behind Fido. It's a good read. I will send you the blog, maybe in the chat itself after the session. So things like, there are so many concepts like manufacturing server, then we have onboarding device client, so many different concepts there to read about. And you can use that blog to, even if you want to try out how to set up a FTO server, you can do that as well. So this is a critical component when it comes to managing edge devices, and edge devices even at scale, so establishing security and so on. So from here, I would like to go back to the, I like to put that blog in the chat. Let me take that. Okay, I think I found it. Okay, I have it. I put it in the comment section. Ah, Jinesh, I cannot comment. So I will give you the link so that you can comment later.
Yeah,
All right,
sure, we'll do. Yeah, you can add in the description of the video, so all the useful resources, including the lab link. Yeah, that will be useful.
sure.
Yeah,
All right, and that was all about our session. Maybe in the future we can show MicroShift once it's technology preview ready. The packages
sure.
are there for us.
We have to. Yeah.
any
Okay.
any questions for us?
Yeah. Yeah. Thanks all. Actually, it was awesome. Actually, a lot of information, and the good thing is you can see the lab is ready to use. We don't need to set up anything. We don't need to worry about the infra. So I think anyone can simply. I mean, I think even you don't need to log in, right?
No, we don't have to register. It's just a
Yes.
open website. So let me go to
Yeah.
the the page of the lab itself.
Okay.
So let's show how does it look like. So lab.redhat.com. You have all these different labs for you to
Okay.
play
Great.
around.
Yeah, this
So
is
that's
good.
what
Yeah.
at
So
Enterprise Linux, right? And
great.
keep on visiting this lab. When we started this lab, we had only 5 or 6 scenarios. It looks like we had 20 plus scenarios right now.
Yeah, I think you can see most of them, like the scenarios which we cannot really simulate in our own setup because we need multiple components here, like including the hybrid console we have already access. You don't need to worry about the login. So this is good. Hmm. Okay, I will add the link in the description so that anyone can, if someone missed this video, they can watch it later and use it. Okay, thank you so much. Okay, I think we will see if we have any questions. Uh, yeah, okay, we will wait for that. Any questions or something? I just want to share. So this is like the lab. Utilize the lab because I know most of them we have a similar labs for Ansible and OpenShift. So this one is also good, actually very good, because most of the time we cannot, some items we cannot really simulate from our workstation or laptop or desktop. So this one you have already access. You don't need to worry about the login to the hybrid console. You don't need to worry about the virtual machines or virtualizations. I think it's already ready to use. And even the commands, as Rahul mentioned, you don't need to type actually. If you type, you will remember anyway. You can simply copy paste to make it like how it's working and what is the concept, and read the instruction so we will understand, okay, what is it. It's very good actually. Yeah, good. I think I will try this tonight. I mean, I miss this lab, I think. Okay, great. um Again, do we have any questions, anything not clear, so we can.
Yeah, if any questions, we can put that in the YouTube comment box, right?
Yes, anytime anyone can access. Anyone can just ask in the comment later. We will try our best to reply We will try our max best to include all the links, resource details inside the description. So if you miss anything, yeah, please ask. Explore the lab, utilize it. It's free. Yeah, I think there won't be much issues on the resource part. I never seen any issue. You start the lab, you will get it. Unless
Yeah,
you are like 50 people attending to it. Otherwise, it's fine.
that's right. Yeah,
Yeah, it's
totally.
great.
And
Yeah.
it's slightly slow, but gets the job done.
Yes, yeah. So, you have any idea what is the timeout for the lab? It's like 40 minutes or 1 hour?
I think once you start the lab, probably 1 hour. 1 hour is a timeout for this particular lab.
Okay,
So
great. Yeah, 1 hour
I
is more
think,
than enough.
yeah, we should finish within 1 hour. One hour is good enough for this lab actually.
Okay, great.
And whatever
Okay,
you have done will be there. Like I have been doing this from Friday, Saturday, and Sunday. All those things.
okay, great. Okay, I think this is good. Okay, I think the explanations are very clear. We don't have much questions. And the audience, thank you for joining, everyone. Hopefully, you'll have more sessions, especially the microshift part. Very interesting one, the lightweight one. Hopefully, very soon. Yeah. Okay. Maybe we can wait a few more minutes. Otherwise, yeah, we can end the session.
Okay, sure.
Okay.
Let's do that.
Yeah. Okay. If you are if you are looking for some specific topic or some kind of related topic on RHEL or OpenShift or MicroShift, please just inform us, just ask somewhere LinkedIn or in the comment box anywhere. We will try to arrange some sessions like knowledge sharing because now it's like online. Sometimes we do the offline one, and last time we realized that okay, when we do the in-person one, now everyone say okay, there was a session. How can we attend? Is there a hybrid mode? No, we unfortunately some of the session we cannot do hybrid because it's really not practical. That's why we thought okay, we can do something like these slides knowledge sharing sessions so that people can ask questions and clarify the details.
Okay, Jinesh, I think this Wednesday night, Wednesday or Thursday, let me check. On 16th November,
Okay.
we are going GA on OpenShift 4.12.
Wow. Okay.
There's a YouTube live session, which happens. It's done by our product managers globally. So it's
Okay.
what's new in 4.12, happening at Singapore time 10:30 p.m. It's a
Wow.
time.
Okay.
If you miss it, next day morning you can watch it anyway. Yeah.
Correct. Yeah. Yeah. Okay. Okay. I think I will include that link in the description. So if anyone interested, they can watch it. Yeah. That's good.
Yeah.
Yeah. Great. Okay. I think we don't have any questions. In that case, we can end it. And Rahul, thank you so much for joining us today. Actually, it's a lot of information. Seriously, so this is very good. Hopefully, we will have more sessions. And yeah, thank you again. Anything you want to share with the team?
No, no, it was my pleasure to join this session. Thanks for inviting me. Actually,
Sure. Thank you.
definitely in future we will meet again for sure.
Sure. Sure. Sure.
Thanks for
Thank you.
once again. Thank you.
Thank you. Thank you all. If you have any questions, please ask later in the comment box. And see you next time for another knowledge sharing section. If you have any specific topic or request, please let us know. We'll try our best to cover it. Also, if anyone want to talk, please let us know. Sharing is caring. Okay. Thank you. Thank you all, and good night. Bye
All right,
bye.
Dinesh. Thank you. Thank you then. Bye.